Welcome back. In this video we are going to be discussing section 9.8 of your textbook, which begins on page 606 and is entitled Factor Polynomials Completely. So before you have factored polynomials using different methods, eventually you got to a point where that a value in your standard ax squared plus bx plus c form, a was not 1, so it became a little bit more challenging factoring this c as well as factoring this a. Alright, so in this section we're going to be discussing another method other than just your plain old trial and error. So you have used the distributive property to find the greatest common monomial from a polynomial, and you've factored that out. So sometimes you can factor out a common binomial instead of a monomial, so we'll have two terms instead of one. So let's look at an example. Factor the expression. So as you can see, there is a common binomial here. Alright, in both of these chunks, I will go ahead and call this chunk 1 and this chunk 2. So it has that common x plus 4. So I can sort of use a reverse distributive property here, and I can factor out an x plus 4 from both of those. And as you can see, what is remaining, those numbers and monomials out in front become a second set of parentheses. Alright, so there they are. Alright, when you factor out that x plus 4. So let's go ahead and look at another example, throwing you for a little bit of a loop here. So as you can see, this set right here is a y minus 2. And then you can see this second set is not y minus 2, but is 2 minus y, but you can see the same numbers and the same variables. So maybe we can do something about that so we can factor out a common binomial. So the binomials, y minus 2 and 2 minus y, are opposites. So from this second piece here, I can go ahead and factor out a negative 1. Alright, and when I factor out a negative 1 and make that negative 5, this should become y minus 2. So it's like dividing each of the 2 and the y by a negative 1. Alright, so they do that, and now since they have that common binomial, they can go ahead and factor out that y minus 2, and then put the remaining, what's in front here, the blue terms, in their own set of parentheses. Alright, and if you were to go through the entire distribution process for the record, you were to distribute, you use your rainbows here, and then combine your like terms, you would see that it would be the exact same as if you were to FOIL out the bottom set of parentheses. Alright, so grouping, this is going to be more of our fail-safe method. You may be able to use the distributive property to factor out polynomials with 4 terms. Factor a common monomial from pairs of terms, and then look for a common binomial. So we're going to be adding in a couple of steps and then doing what we just did in those previous couple of examples. This is called factor by grouping. Alright, so instead of having to go about this trial and error process, you can use factor by grouping. So example 2, factor the polynomial. So what's going to be helpful for you is to make sure that they are listed in decreasing polynomial order. Alright, so you have an x cubed, you have an x squared, this is an x to the first power. Alright, there is a 1 there that you do not see. Alright, and then this is x to the 0. Alright, you don't even see that x, that's your constant. So it's in decreasing polynomial order. And we're going to separate these into 2 sets. Alright? So when I separate them into 2 different groups, I can then look at the 2 terms that I have and factor out what they have in common. So what is their common monomial as far as coefficients and variables are concerned? Alright, for both of the sets. So in this set, the first set, I have an x squared, I can take not only one x, but I can take two x's out. So that is an x squared. And then in order to undistribute, what I do is I divide both of these terms by an x squared. Alright, you're undistributing that, and that leaves me with an x plus 3. And here in the second set, I recognize I've got a 5 and a 15. So they have a 5 in common that I go ahead and pull out here. I undistribute, and I pull it out in front, and that leaves me with an x plus 3 after I divide each of those terms by that 5, and I undistribute it. So then, from each of those sets, each of those groups, I can go ahead and undistribute the set of x plus 3, and that leaves me with the x squared plus 5 in the second set. So let's go ahead and look at example 2b. Alright, yet again, I'm going to break this into two groups. Alright, see what they have in common and pull those terms out in front. So I have separated them into two groups, and I recognize in my first group I have a y in both of the terms, one y, so I undistribute that y. And in the second group I have an x in common with both the terms, so I undistribute that x. Then I factor out that y plus 1, and I'm left with y plus x. Alright, so here's example 3, and I want to go ahead and see what I can do to tackle this one. Now, if you're observing, this is an x cubed, then you have your constant, and then you have your single x term, and then your x squared. It's not in order, so what we want to do is write it in proper polynomial decreasing order here. Alright, so the terms x squared and negative 6 have no factor. That should be an x cubed. Alright, so we're going to need to use the commutative property to rearrange the terms so that I can group them properly. Alright, so I do that, and they're now in decreasing polynomial order, and I'm going to go ahead and break them into two groups. And then I recognize their common monomials for each of the groups, and I should result with a common x minus 3. Now I can't factor out that, these sets that are left over after I undistribute if they're not the exact same. So we better get the exact same when I factor out those common monomials. And so I factor out that x minus 3, and I am left with the x squared plus 2 in the second set. Alright, so double check here. You can check your factorization using a graphing calculator. If you're lucky to have a graphing calculator, you're going to want to go to this upper left y equals button, and then you can type in these equations. Now you can type in your original equation and then your factored equation, and you should get the exact same graph. If you do not, then you have not factored it properly. Alright, so here's a couple of guided practice. Of course, feel free to pause the video. Solutions will be popping up here in a second, and double check those, see if your solutions match. Alright, as you can see in the third example, it has two variables, and it's gonna take you a couple of tries maybe to factor these and see which terms they have any common monomials with. So it might have not been your first arrangement. Had I looked at it, this y squared has a y in common with this, and then I could rearrange it and factor out a different way. So had I done that, I would have slightly different work, just like I do in the pink, but my final answers would end up being the exact same. As far as proper factorization, my commutative property would just allow those answers to be a little bit different. So you might have a slightly different answer than somebody else, but that does not mean you're wrong. That just means you tackled the problem a little bit differently. Alright, so here, factoring completely. You have seen these special factorizations where x squared minus 1 can be factored as x plus 1 times x minus 1. That is the difference of squares. Whereas if I have something like, this x squared plus 1, we don't have any pattern that leads us to, something called sum of squares instead. So that polynomial, the x squared plus 1, is not factorable. Alright, so it is called unfactorable, which is right here in this paragraph. It is called unfactorable. If a polynomial is factorable, you're going to have integer coefficients. So you're seeing these numbers down here like 3 and 6, and technically there's a 1 right there. These 1s and 2s and 3, like, you're seeing nice clean numbers. You're not seeing these decimals, you're not seeing fractions, alright? So if you are going to factor completely, it's going to be written as a product of unfactorable polynomials with integer coefficients. And reading over here, this sidebar in your book, if a polynomial has 2 or more terms, it is unfactorable. And if a polynomial has 2 or more terms and is unfactorable, it's called a prime polynomial. So hopefully you know at this point what a prime number is. We've got 2, 3, 5, 7, 11, 13, 17, ... Alright, these are numbers that only have a factor of 1 and themselves, and so they just can't be factored nicely. Alright, without using square roots or fractions. So here are a couple of guidelines of how to factor completely. Hopefully you write those down and you have those ready to go when we get to an assessment. So let's go ahead and look at some more examples. Factor the polynomial completely. So first and foremost, you want to recognize if it falls into a pattern and if it can be factored. Alright, so first and foremost, it is not going to be a difference of squares because it has an n term. And to me, it looks an awful lot like, because I see that too, it looks an awful lot like one of those perfect square trinomials. So maybe I look back at one of those patterns and I see if this can fit the bill. Alright, and then I want to go ahead and try what are the factors of -1. Alright, so what multiplies to -1? It has to be a positive 1 and it has to be a -1. And there's only one arrangement of those numbers. It's 1, -1. Alright, so then when I add those together, I get 0. So there's no possible way that I can actually get, two numbers that multiply to -1 that add to a positive 2. So that means this is not factorable. This polynomial cannot be factored. Alright, there's no factors of -1 that have a sum of 2. I just can't do it. Alright, and one tip here, one piece of advice, sometimes when, an initial gut feeling for me was that this B term, what's sitting in that B spot, is actually greater than C. Now, there's only a couple of instances where B is going to be greater than C, and that's when C is 1. But typically speaking, when I multiply numbers, that C value is going to be bigger than when I'm adding those numbers. So I would just keep an eye out for when B is bigger than C. Alright, so example 4B. Factor this completely. Right off the bat, I see a 4 and I see a 44. I haven't disregarded that 96, but I see a 4 and a 44, and I think, well, maybe I can factor something out. Then I see x cubed, x squared, and x. I better try factoring out a number and making these numbers smaller. So that's going to be my first step. Each of those terms has a 4x in common, so I factor out a 4x. Then I can split up that 24. What multiplies to 24? That adds to a -11, and that was that -3 and -8. Alright, do keep in mind that, these signs have a, dog in the fight. That means both of the signs are going to be negative. So would you check that out? 2 negative signs. Alright, example 4C here. Factor the polynomial completely. Look at the terms. Do they have anything in common that I can factor out initially? Why, certainly they do. They've got a 2h squared. I can not only take out a 2, but I can take out an h and then another h as well. Alright, and that leaves me with 25h squared minus 1. Alright, so 25h squared and a 1 are all perfect squares. So I'm going to factor that as a difference of squares. And I'm going to end up with 2h squared times the quantity 5h minus 1 times the quantity 5h plus 1. And here's a couple guided practice. Why don't you go ahead, pause the video, and see if your solutions match. Alright, and here in example 5, they're just adding on one more step for you. So, when we go to solve instead of factor, we are just going to continue the process after we factor and use the zero product property. In order to use the zero product property, I need to make sure it's set equal to 0. So, step 1, go ahead and add 24x, go ahead and move that 24x, undo what's being done, it's negative, so I need to add it to both sides, and so that I get that beautiful equals 0, so I can use that zero product property. Alright, so then I look at all three of my terms. I've got a 3 and an 18, and I know that they certainly have something in common. They also have that number in common, 24, so I'm able to factor out a 3x out of all those terms. And then I look at the factors of 8. What multiplies to 8? That adds to a positive 6. And that should be a 2 and a 4. Alright, so my final factorization here is 3x times x plus 2 times x plus 3. Or sorry, x plus 4. And that equals 0. So then I can use my zero product property. Now, this is one of the first instances in which you are seeing an x out here in front, as well as x's in both of these binomials that you factored. So, using the zero product property, you need to test 3 different pieces. Alright, so you are setting each of those pieces with variables equal to 0, and then you are solving. So in this first one, you need to divide by 3, and the second one, subtracting 2 from each side, and then in this third one, subtracting 4 from each side, getting these 3 solutions. Alright, so the solutions are 0, -2, and -4. How I would write it is x equals 0, -2, 4. -4. Alright, you can write it either way. So here's a guided practice for you. Pause the video and see if your solutions match. Alright, now example 6, a word problem for you all. A terrarium in the shape of a rectangular prism. It has a volume of 4,608 cubic inches. Its length is more than 10 inches. So right away, that more than 10 inches, I have a gut feeling that we'll end up solving and we'll get multiple answers here, but a couple are probably going to be less than that 10 inches. So that will rule out some of the final solutions. The dimensions of the terrarium are shown. Find the length, width, and height. So here is my length, that is 36 minus w. Here's my width, w, and my height is w plus 4. So write a verbal model, then write an equation. Alright, here's my verbal model up on top. I've got my volume, and hopefully you guys know a formula for volume. That is length times width times height for a rectangular prism. And just filling in those variables with their parentheses. I get 4,608 times the quantity 36 minus w times W times the quantity W plus 4. Alright, so when I go to solve these, I need to use some distributive properties here, and I need to get everything on one side. So the steps that they miss, between step 1 and step 2 here, I'll go ahead and write up in the top right for you. Alright, so I use my distributive property, and then I use the FOILing process, and then they subtracted that 4,608 to both sides and combined their like terms. Alright, so there's a couple steps of missing work up in your upper right. Alright, so when I go ahead and factor by grouping, I break this line into two different pieces here, and you would notice that you do have common terms. There is going to be a number in common between those two, but they go ahead and they reorder it anyways because they notice that W cubed and 4,608 don't have a common term other than that -1 that they can factor out. So they reorder it in decreasing polynomial order, and they group the terms, and then they factor out those common monomials between those two terms, and they do get a common W minus 32. Alright, so then they can factor out that W minus 32 and get negative W squared plus 144. Alright, so now what they do is they go ahead and they factor out that -1 because typically we don't like that negative leading off a binomial. So out of both of these terms, they factor out that -1. Now, one thing I say that you could probably do in reverse is use your commutative property and write this as 144 minus W squared instead. So then right there, it actually falls into the difference of squares without having to factor out that -1. Alright, but really in the end it's not going to make a difference. So, with that -1 being factored out, I need to continue factoring that term. Alright, and that factors into W minus 12 times W plus 12. So this is my full factorization, and now I need to go ahead and solve each of these pieces using my zero product property. Alright, so I set each of those binomials, each chunk, each group with a variable equal to 0, and I solve. Alright, so those are my three possibilities. And as they said, in the beginning of the problem, it has to be, we're talking about lengths here, so that gets rid of this one because it was negative. Alright, so that's my width. Choose the solution of the equation that is correct for W. So when I go ahead and find my length, width, and height, using those two W values, alright, so 12 and 32, I need to think about the restrictions that they said in the beginning of the problem. So disregard -12 because we can't have a negative width, and you know that the solutions, that the length has to be more than 10 inches. So test the solutions of 12 and 32 for the length. Alright, the length formula going all the way back was 36 minus W. So when you substitute in 32, that wouldn't work out, but when I substituted in 12, it would have worked. Alright, so it had to be greater than 10. That's greater than 10. This is not greater than 10. Alright, so the solution 12 gives me a length of 24 and the correct width of 12. So then I need to go ahead and find my height. W plus 4, 12 plus 4, 16. So my final answer, W equals 12, L equals 24, and H equals 16. Alright, so here's your final guide practice. Pause the video and see if you can get the final solution. Yes, it's a lot of work, but it's worth the challenge. Alright, so hopefully you came out to the length as 3 feet, the width is 2 feet, and the height is 12 feet. If you guys have any questions, feel free to send me an email. Good luck.